Good morning, folks. Welcome to AWS CloudFormation Best Practices. As folks are coming in, we'll go ahead and get started. I'm Abhishek Lal. I'm the product manager for CloudFormation, and excited to be here today with Chris Whitaker.
So I'm Chris Whitaker. I'm the dev manager for CloudFormation.
And together, we want to take the next hour and cover several best practices related to CloudFormation. If folks are not familiar with CloudFormation, it is your infrastructure as code service. Just as you write code, version it, update it, you can do the same with all your AWS resources, all your infrastructure resources. CloudFormation not only lets you declare infrastructure as code, it actually takes care of all the ordering and provisioning of your resources based on the dependencies between them, letting you not do all the hard work of figuring out which resource needs to be created before and after or dealing with individual APIs, giving you a single consistent interface to provision resources. It also integrates with development processes and CI/CD tools, other management tools, to provide you a great platform to build your applications and infrastructure end-to-end. For the session today, I'm going to kick off by introducing the CloudFormation Designer. This was a new feature we announced last week, so we'll spend about 20 minutes walking through the designer and seeing what it is capable of. After that, we will go into some areas talking about how CloudFormation can help you as an organization. This could be about budgets. This can be about audits. There are a lot of organizational features which CloudFormation can really help with. Chris will be presenting that section, followed by some advanced concepts as well as best practices. These will include security. These will include being able to write templates which are reusable, as well as making you aware of some of the language features that we have in CloudFormation. So just wanted to set the agenda. These are the expectations, and we hope to finish about 10 minutes early to keep some time for question and answers. But as sessions go, if we do not get to that, Chris and I both will be available here after the session to take your questions. And I believe the room is empty, so we'll have a lot of time for that. And if that doesn't happen, we will be at the DevOps section of our booth. So any questions you have, you'll be able to talk to us. AWS CloudFormation Designer. Today, when you create resources in AWS, there's an ever-increasing set of different abstractions and resources that AWS services provide you. Being able to visualize these resources, which are part of a template, was a key customer ask. Hence, we worked on CloudFormation Designer, which lets you see all your resources, which are part of a template, in a visual designer form. Once you are able to visualize them, the next step folks asked was, how do you make quick modifications? Be able to hone in on a specific resource that you want to quickly modify, and then be able to upload those changes. That is a scenario supported by the CloudFormation Designer. The third aspect, and which I'm going to walk in detail today in my demo in the next 15 minutes, is how do you actually start from a sample or start from just a basic architecture and evolve it using the designer. So we will see all those three scenarios. The first one, which I just want to show you, is the ability to visualize a template. Let me log into the AWS Management Console. And here I am on my CloudFormation homepage, which is where all my stacks are listed. You can see for any particular stack that I select, in this case a demo website, there is a description which the template may have contained, and there is a resources tab. So this resources tab is what displays all the individual resources that the template has defined in it. As you can see, it's a fairly flat view. It doesn't give you any knowledge about relationships. It doesn't give you any knowledge about dependencies that may exist between these resources. With CloudFormation Designer, I can just take this selected template and view it in the designer. So right here, you see in this example, I have a VPC-based website where it gives me a nice indication of all the relationships. So at the top, I have an EC2 VPC, network ACLs, the specific ACL entries, as well as relationships. So for example, the internet gateway, the IP address, and how each of these resources are connected to each other. I can also see my EC2 VPC and the subnet that it is part of. So in this example, we see how very quickly, for any CloudFormation stack which you have created from a template, you get to visualize and view all of those resources. Now, once you've seen something, how does the designer help you in making an update? Let's take a look at that. The scenario I'm going to walk through here is I have a particular website running, and the EC2 instance is part of a security group. What I want to do is figure out if SSH ports are enabled, and if not, then enable them. So a very small kind of a modification. So I open my demo stack, which is basically a single EC2 instance, and I do view in Designer, just as I had navigated in the earlier part of the demo. So a very simple stack. It has two resources in the template. I can hover over each of the resource, see what type it is. I can actually select a particular resource. And the moment you select a resource, you'll see the Components tab at the bottom gets populated with all the declaration that template has for it. So in this case, I see all the references and the description which I have added for my EC2 instance. Let me select the security group, because that's where I need to make a change. In the security group, I have the ingress of port 80 available, but I can clearly see that port 22 is not there. So how do I add that? Let me click into the Components tab. The Components tab lets you focus on a single resource and make modifications to it. I press Control space, and I see autocomplete for all the properties, which is there. So very quickly, I can specify which protocol. I can specify the from port, the to port, and all the specific properties that I want to define. The advantage here was, if I'm not familiar, I didn't have to go refer to documentation to see what the exact property name was. All of that is available to you using code autocomplete. I make those changes, and in this case, I'm going to add the IP range to this. Just to call out, for this demo, I used zero, all zero. This is clearly not best practice. So yeah, do not take a picture of that. But once I've made this update, I can now go and click Update Stack. And right from here, with all the changes I just made, I get dropped into the Update Stack wizard. I can make any parameter changes or any updates, which in this case I don't. need to, I click through the wizard, and I can update the stack. So what you saw was how powerful the designer can be for you to hone in on a particular resource, be able to make quick modifications, and then with those modifications, update your existing stack in there. So I've finished the update procedure. You can see the update is in progress. User initiated is the state. Let me go refresh the portal. And you can see as the update propagates through, the CloudFormation Designer will show you all the events and eventually show the update has completed in this case. So that was the part about making a quick modification. Can you actually do authoring? Can the designer help you with authoring a template and doing some rich work in there? Let's see how that comes about. In this particular scenario, I want to start with the same website I had. It's a single instance with a security group. So I'm going to start with the very same website which I had, a simple web application. But I'm coming with a goal. My goal is to make this a highly available website. What do I need for that? I need to make several changes. I need auto-scaling for compute. I need a load balancer. So I need to make some very rich edits in order to take this website and make it highly available. How do I do that? Let's see it step by step. The first thing you see is the resource types listed on the left. These are all resources supported by CloudFormation. We will continue to keep 100% parity with CloudFormation support and the resources that you have available in the designer. I start by dragging in the auto-scaling group. So simple drag and drop gesture, and I can give this a logical name. Clicking on the checkbox, now I have an auto-scaling group available to me. Just as I did earlier, let me start typing in the properties. I am familiar with auto-scaling groups. So in that sense, I know all the key properties that I need to provide for an auto-scaling group. Availability zones is one of them. The next one which I'm going to add to the auto-scaling group is the min size, the max size, the desired capacity. So if you're familiar with a resource, very quickly you can use code complete and add those properties. While you're making all these edits, note how the designer pane, the visual pane, stops refreshing. What is going on here is the component view lets you modify a particular component, and until you have a valid component, that is, you made only valid changes, the designer will not sync or commit those changes. So clicking on the top right refresh is what committed all the changes I needed for the auto-scaling group. Now, notice the dots you see on each of the nodes. Those are clues about what auto-scaling group is related to. So one of the nodes I see in there is a load balancer. So I scroll down, find a load balancer, and put that on the screen. This, unfortunately, is not a resource I am familiar with. I do not know how load balancers are configured. I know what it is, I just don't know how to configure it. So I right-click and navigate to help documentation right from the resource. So right here, you get dropped into the CloudFormation description of a load balancer resource. Now, I'm a very fast learner, so I'm just going to scroll at the speed of light. But most of us will take some time, read through all of this. And the good part is, it tells me what are all the required fields and the non-required fields. So it really helps me narrow down on what are the key properties I need to focus on. So with my newfound knowledge, I'm back. And now I can start typing in all the properties that I want to specify. So in this way, we've helped you in the experience of authoring, where you can find resources, You can find what is related to them, what are the most common relationships that you create, and based on that, go discover the documentation and help for those resources. In this case, I create a single listener instance port, which is port 80. And given the documentation told me that I need to specify the protocol, I will make sure that I add the protocol as one of the items here. So protocols HTTP, and with that, I have made all the basic requirements which I needed. Go on top right, click refresh, and I'm ready to go. Now I'm going to drag and drop this relationship between the auto-scaling group to the load balancer. Note the highlighting. When you drag and drop from a particular node, we highlight those specific types of resources which you can create relationships to. The one remaining item which I have to complete this operation is adding a launch configuration. Now, if folks are familiar with launch configurations, they are essentially used by an auto-scaling group to stamp out new instances. So they have a lot of properties which are very similar to an instance property. Now, I would want to copy-paste all the parameter values that I have from my instance to my launch configuration. Since this is a heavy edit operation, copy, paste, and placing, I'm going to switch to the template view and maximize that pane. This is the editor pane in which you get a full view of the template. In the designer, we have still not visualized some of the things, for example, the description or your parameters or outputs. These are things which are not visualized in the designer. So you always will have the template view to come in and be able to make your edits. In this case, I copy all the text which was part of the instance, and I scroll down to find my launch configuration. And in here, in the properties, as is, I can paste all of that changes. So with that, I'm done with my edit. Let me bring back my designer view and click refresh to be able to see all the changes. See how that relationship showed up. The relationship from the launch configuration to the security group is now available. The web server instance is no longer needed. I can right-click, and we have a delete context menu right there. So I will use that and get rid of the instance in there. The one last step remaining for my change is to create that relationship from the auto-scaling group to the launch configuration. I navigate to the right node. Notice how launch configuration has lit up. So it gives me a clue that those are all the resources, and I create that relationship in there. So all good. I've made a bunch of changes. I'm feeling really good about this. What's the next step? The next step is to validate. So I'm going to click Validate Template in here. This is the first time where we're going to send this template back to CloudFormation as an API call and validate for errors. Oh, I see an error right here. It says I'm using a function getAt for a resource called web server instance. That's right. I had a web server instance, but I don't have it anymore. I have replaced it now with a load balancer endpoint, which I need. So now I'm going to replace the logical name from web server instance to the load balancer, because I want the public DNS name to come from the load balancer. So validate template helped me there. I've made my change, hit refresh, and validate again. Should all work. Oops. So clearly I've got a mistake. So public DNS name. Why doesn't a load balancer have a public DNS name? That's sort of odd to me. Let me go back to the documentation. Since load balancer I was not familiar with, I can again reference the documentation and look at what are the getAt values which a load balancer provides me. These are the output values. And I quickly notice it's not public DNS name, it's DNS name. So I can copy that value over, bring it to my template designer, and quickly make that change. So you see how we are helping you with the validate function to be able to quickly make these changes and checks and not have to go through full deploy and update cycles. The deployment will still find errors if they exist, which are outside of the validate template. So I want to make sure that I save my local file. Because once you go and update the stack, this template will no longer be available if the update fails. So I do a file save as and save this file locally. So I have a valid template, all of my changes ready to go. And at this point, I can click launch and go update my stack in there. So really quickly, we saw how easy it was to start from a simple template, make additions, make updates, create relationships, and be able to upload those changes in there. So I want to quickly recap all the different aspects of the designer which we have demoed today and showed you. You saw the toolbar navigation. This is where you're going to open files, save files. You're going to do validation of your template, both from schema validation when you send it to the service, as well as the refresh on the right, which validates whether the component level JSON meets the basic requirements. The resource palette. This will contain all of your supported AWS resources, which CloudFormation supports. It's organized by service, and you can drag and drop this onto the canvas. We've used the same color coding for icons that you see in all of the AWS sort of services, so that should help you give a visual clues on that. The designer canvas, we saw how it helps you with all the different relationship types. You saw containment relationships. There's arrows relationship. We've got references. We've got depends upon. We've got function get-ats. All of dependencies are visualized within the designer. And finally, the code editor. In the code editor, not only were you able to open your existing template and be able to format it, but actually use control space code completion and get some help with what are the properties available, which you may not already have specified in there. With that, I conclude the section on CloudFormation Designer. I request you guys to go give it a try. We'd really appreciate feedback on that. It's a new feature, so we're going to iterate quickly on it. And I'm going to hand it over to Chris to walk you through the rest of the sections. Thank you.
Cool, thanks, Abhishek. So we'll start off just by talking about what are the services that CloudFormation supports. When you think about code as infrastructure, you typically think about network, compute, storage. But what CloudFormation provides is a much more comprehensive, broad set of services, ranging obviously from network, compute, and storage, but also including things like the application, things that you need like queues, streams, whatever you need to build the application. So any of those things that you need to build the application, you can also include in the template. And we're also moving up the stack, so we'll go through them, but if you look at there, we also do things like code deploy. So not only can you deploy the infrastructure you need to build the application, you can also start to deploy some of the operational pieces that you need in order to run it once it's there. And then at a higher level, things like Amazon Workspaces, where maybe you want to deploy a new account, it has VPCs, it has all the kind of infrastructure pieces, but you may also want to put some of the enterprise management tools in there as well. So let's go through some of the new ones that we just added. So we've extended Lambda we now allow you to support event sources. So if you use Lambda and you have Kinesis streams or DynamoDB streams, then you can use CloudFormation to connect the Lambda function up to those streams. We also support now spot fleets. So spot fleets is a feature that EC2 provides. It allows you to create a set of instances with spot price. So you can use spot prices to create instances. It's a fleet. You give it the size of the fleet that you want and the bid price, and it maintains how many instances are in that fleet. So now you can create fleets using Spot through CloudFormation. We've extended out the RDS support, so we now support Aurora. We also support the new database that we announced yesterday, so that all of the RDS database engines are now supported through CloudFormation. We've added simple AD, so you can create simple Active Directory within a CloudFormation template, and you can create any instances and join them to that directory within the template. So you can now create a fully AD managed system through a CloudFormation template. We've added code deploy. So now you can use CloudFormation to create the infrastructure and set up the application and the deployment groups that you need in order to deploy code through code deploy once all that infrastructure is in place. So that's kind of a nice interaction between CloudFormation to manage the infrastructure and then code deploy to manage the application lifecycle. And like I said before, we've added workspaces. So if you provision your new accounts and you want to put workspaces in there for customers to use in that account, you can now provision that too. So let's talk a little bit about CloudFormation and what it can bring to the organization. So last year, we talked a little bit about using Cost Explorer with CloudFormation. So whenever you create resources from a CloudFormation template, we'll tag all of the instances, all of the resources in that template with the stack ID and the stack name. So any of the resources will be tagged automatically. You can use that within Cost Explorer and now within budgets to actually just figure out what is the cost of the stack. How much is this stack costing over time? And with budgets, you can actually do an analysis of what will this cost. So it gives you some history. It uses history to figure out what's going to happen in the future. And then you can add notifications to that. So you can say, I want a notification if I'm going to hit my whatever cost limit I put on that. Or I'm going to add a notification if we think this is going to hit the cost limit within that month. So you have some flexibility there to use stacks and to be able to manage the cost of a stack and budget the cost of a stack through using the tagging that we provide. CloudFormation is integrated with CloudTrail. So whenever you make an API call, either through the management console, through the SDKs if you're automating on top, or through the CLI, all of those API calls to CloudFormation are logged in CloudTrail. As are a lot of the other services, and it's a growing set of services that are integrated with CloudTrail. And so what you'll see is CloudTrail will collect all of those logs. You'll see the CloudFormation entries that say, I created a stack. You'll also see CloudFormation called all these other services to create the resources. So within the CloudTrail logs, you can see the full history of what happened as you created the stack or updated the stack. And you can store that in an S3 bucket. You can archive that data. You can use the CloudTrail console to look through those logs to troubleshoot what happened. Or you can connect it up to CloudWatch logs and then add monitoring and alarming on top of that. So if things happen that you don't expect to happen, you can get notifications for that. So let's look a little bit about some of the CloudFormation language features. So Abhishek used a few of the features. The language that we have has a few, we call them intrinsic functions, built-in functions that allow you to provide data to some of the properties that you might need. So we have things like base64, which is typically used to fill out the user data area in an EC2 instance. But obviously, you can base64 encode anything that you want to pass into the template. There's a few conditional functions, and we'll talk a little bit more about conditions later on. We have functions to find in mappings, and we'll talk a little bit about mappings later. And then there are some other functions like getAt, which Abhishek showed, which is really about, I have a resource, I want to be able to get some of the properties that were there as a result of creating those resources. So for example, I may want to get the DNS name of a load balancer and use that somewhere else in the template. So I can use getAt for that. We have some functions to do things like join strings together, select entries from a list, things like that. And then we have ref. What ref does is that really gives you the ID of the resource that you created. So if you create the load balancer, you get the load balancer ID. If you create an instance, you get an instance ID, and so on. So you can use that as data in the template. So let's talk about extending CloudFormation. So there's multiple ways to extend CloudFormation. You may have resources that CloudFormation doesn't yet support in AWS, or you may have resources that are not AWS resources. So let's take a look at that last example. So let's say I have a stack. This is a fairly simple kind of web application, has a load balancer, has an auto-scaling group with instances, CloudWatch alarms, code deploy, and maybe a cache. And I want to link it up to some web analytics service that's outside of AWS. So how might I do that? So the first way to look at it is CloudFormation, obviously, you can use CloudFormation to create the stack. As you create the stack, any things that CloudFormation does, we send out as events. So every time we create a resource, we'll send a create event. Every time we complete creating that resource, we'll send an event. So you get a full life cycle of events, and that shows up in the events tag on in the console. You can also subscribe an SNS topic to that event stream. And then from there, obviously, you have an event stream of things that are happening as the stack is created. You can do whatever you want with that event stream. So in this example, we may attach a worker to that SNS topic, and as the stack is created, at some point, based on which resource it is that we want to, or whether it's on stack completion, we can then use a worker to register that stack into my web analytics service. So that's one way of kind of extending out CloudFormation. With this model, the entry in the web analytics tool is created asynchronously to the stack. So CloudFormation knows nothing about the web analytics service. It's just something that happened as a result of the stack creation. So what happens if I actually want CloudFormation to understand more about the things that are not supported yet, or things outside of AWS? CloudFormation has a notion of custom resources. So custom resources is our extensibility point for resources in CloudFormation. Let's take the same example. I have the same website again. I have the same web analytics. Now I want to be able to describe in my template that I actually want to register with the web analytics service. So I can create a resource. I can add the definition of that resource into my template. A custom resource definition looks just like any other resource definition. Has a type. Type something you define as the user of that, or the creator of that. And it has a set of properties, the things I need in order to create that resource. It has one special property, which is called service token. And that's really an indication to CloudFormation of where to send messages when we get to create that resource. We know nothing about that resource, but we know it exists. So what will happen is, as CloudFormation provisions the stack, it will get to that resource, and it will send an SNS message, in this case, to whatever endpoint you've described. At that point, you've got to create a message, an update message, or a delete message, depending on what the stack operation you performed was. You can do that functionality, register it, in this case, with the web analytics service, and return success or failure if it failed. If it fails, in this case, in a stack create, we'll treat that as a failure just like any other resource failure, as an update. So we'll either fail the stack creation or roll back the stack update. You can also pass back metadata. So maybe when you create this resource, you have some data you want to pass back into the template to use further in the template. So maybe I'm passing the tracking ID back here, that I can then use later on in the template. So it looks and feels to CloudFormation just like any other resource. Just go back to that. So in this case, the assumption is that the endpoint, in this case the Web Analytics Service, understands the SNS protocol that CloudFormation uses. If the service itself doesn't understand that, then you can create what we call a bridge, a custom resource bridge. And that's really a protocol converter, if you like. It takes the inbound messages and does whatever functionality you need to call on the other end. Obviously, to run that bridge, you need to run it somewhere. And we have, in the previous reInvent presentation, we described different ways to do that. But you still do have to run it somewhere. And so what we did this year is we added Lambda-backed custom resources. So that gives you a way to create custom resources where the implementation of that resource is really implemented using Lambda functions. So you don't have to run an EC2 instance somewhere to do that protocol conversion. So in this case, you can add a Lambda function. The only real difference between a custom resource for Lambda versus a custom resource that uses SNS is the service token. In the case of Lambda, it references a Lambda function, and that's the function we'll call. From there, you can do whatever you need to do within that Lambda function. So here's some examples. You might decide that I want the Lambda function to look up Army IDs. Maybe I have custom Army IDs. Maybe I'm looking up what's the latest Windows Army ID or the latest Amazon Linux Army ID. I can use a custom function to look that up, calling the APIs, and then return that data back to CloudFormation to use later in the template. I may want to look up VPC IDs or subnets. If I have chosen to split my implementation into multiple stacks, maybe I have a VPC stack that contains the VPCs, the subnets, and all the network configuration, and I have a separate stack, which is the application stack, and I want to be able to get that VPC ID and that subnet ID so that I can pass it into where I want to create the instances. And so I could write a Lambda function that looks for the specific VPCs or the specific subnets and returns that back into the template. Or maybe I just want to do other functions. We support things like join and select, but maybe you want to split a string and return pieces of a string, or maybe you want to reverse a string, or whatever you want to do. You can pass data to that function and return data back from that function and use later in the template. So that's kind of the use case for extended CloudFormation using 3 different mechanisms that give you different semantics, different properties, but definitely a way to look at if you have resources that are not AWS resources, or if you want to add resources that are AWS resources that CloudFormation doesn't yet support. So let's look a little bit about security. So we'll take this in multiple steps. When you create a stack or you update a stack, typically you pass a template and you may pass a stack policy. For those that don't know what a stack policy is, it's a JSON document that describes what can you do during an update operation. So maybe I don't ever want to update my database, regardless of what happens. Or maybe I'm okay updating it as long as it doesn't replace it. So you can describe policies like that in the policy document. So essentially, when you call create or update, you can pass a template as well as a policy document. What we've added, and we announced last week, is the ability to describe for particular users or roles or groups of users through IAM where those artifacts come from. So for example, on the left there, it shows an IAM policy snippet, which really says for create stack and for update stack, whereabouts is this user, whatever this policy is attached to, where can that template come from? And in this case, it's restricting that user to a specific bucket. So templates always have to come from that bucket for this particular user. On the right-hand side there, It's really the stack policy document. And in this case, we're actually fixing it to say this user has to use this policy document. So it gives you flexibility either way to say either things have to come from a specific bucket or they have to be a specific object as you do those stack operations. So that's one way to kind of restrict user access to which templates can be used, which stack policies can be applied. We then take it a step further, which is maybe your users have permissions to create lots of different resources in CloudFormation, or actually in AWS in their account. But you want to be able to restrict what this user can do within the context of CloudFormation. And so we let you, on a user basis, describe, or on a policy basis, describe which resource types can this IAM principal actually use. So for example, on the left-hand side there, we're saying that this user, or whatever policy this is attached to, they can only create resources of type EC2 instance, and you can add a list there, so that list can be any set of resources that CloudFormation supports. And we also support wildcarding, so you may say AWS EC2 star, if you want to allow all EC2 access. And on the right-hand side, we're saying this user can create anything in the context of a stack except for IAM-related resources. So it gives you a way, by default, the deny will override any other defaults that are there. So we're essentially opening it up, but narrowing it down to say everything but IAM resources. So it gives you some flexibility in how you allow customers to create things in the context of CloudFormation. We also, for those that automate on top of CloudFormation, maybe you build your own infrastructure on top of CloudFormation, maybe it's scripts using the CLI, maybe it's calling the APIs. Create stack and update stack take a new parameter. And what that parameter lets you do is restrict the set of resources or resource types that can be created through this call. So maybe your automation, you know that in your environment, there are only a certain set of things that should be created by this template. Then you can use that new parameter to define the set of things. If anything tries to be created that outside that set, will fail the stack create or the stack update. So I give you some level of control through automation. So let's talk a little bit about templates. So writing templates, one of the things you have to be a little bit careful of, especially if you are giving this template to other people in the organization or even outside the organization, is your environment may be different than their environment. And so how do you write templates that adapt to the environmental constraints that the particular user has? And so here's some examples of things that may change from environment to environment or region to region. Things like Army IDs are different across the regions. Maybe you have to have a template that works in both a VPC as well as EC2 classic environments. The instance types change by region. So the set of possible instance types may be different. Policy names, policy principles may be different. So for example, the elastic load balancing principle you need for logging is actually different in each of the regions. And so you need to be able to define what that is. Or endpoint names. S3 endpoint in US East 1 is s3.amazon.aws.com. Has the region and other regions in that name. Or the ARN format may be different. So for example, if you have to write a template that works in CN North 1, the ARN format for that region is different than the ARN format for other regions. So there's a lot of different things there that you may need to react to based on wherever that template is created or who creates it. So the first thing to look at is kind of pseudo-parameters. So these are variables, if you like, that we pass in automatically into your template creation. And we give you account ID, the account ID of whoever it was that created it. We give you the region in which this template or this stack is being created. And we give you the stack name and the stack ID. So you can reference all of those different environmental properties from within the template. So the example below there sets up a bucket policy for ELB bucket archiving, where we're actually using the account ID as part of the object name in the policy to restrict down where ELB can put its logs for this particular account. Another way to do it is to use mappings. So a mapping is a section in the template that's really used to define a set of variables depending on some selection, if you like, that you want to make. So if you look at the definition on the left-hand side there, a mapping has a name, in this case, regional config. And then within that, you have sections based on some selection. So in this case, I'm using the region as a selection mechanism, US East 1, US West 2. You could use anything there, so it might be a parameter that you type in. Maybe you want the customer to specify small, medium, large. I can use small, medium, large there and have different property values depending on what they selected. Or any other variable or property name you can use to do that selection. So in this case, for each region, I have an ARMY. What's the ARMY ID that I should use for that region? What's the ELB account ID that I should use for logging? As well as what's the ARN prefix for this region. And then within the body of the template, I can use the find and map function. So on the right-hand side there, for the resource in the policy document, we're using find and map from the regional config, using the region as a selector to find the ARN prefix that we should use. So that's another way to get regional or other environmental differences into the template. Another option you have is conditionals. So maybe there are cases where under some conditions you want to create a resource and under other conditions you don't want to create the resource from within that template. Or maybe there are property values that you want to pass in or not pass in based on some condition. So CloudFormation gives you a condition section. And what the condition section does is essentially define a set of conditional expressions that you can use later on in the template. So in this example, I actually have an account that was created before VPC was the default for EC2. And so a lot of my regions have Classic. But the EU Central 1 region and the CN North 1 region were VPC by default for everybody. And so I have an account that is split depending on which region I'm creating it. So in this case, I'm setting up a condition which says, is this EC2 for VPC, or is this a classic EC2 region? And I'm using some of the conditional functions like or, and, not. We have all of those functions as well as equals to actually describe the conditions under which it's an EC2 VPC environment or it's a classic environment. So in this case, I have it's a VPC environment if the region is EU Central or if it's CN North 1. And on the right-hand side is how we use those conditionals. So there's two use cases here. One is for resources, and the other one is for properties. So in the case of a classic region, I want to create DB security groups in order to secure my database. In VPC region, I want to use EC2 security groups for the same thing. What I can do is, at the top level of the resource definition, where you add type and properties, we also allow you to put the condition statement and reference a condition that was defined in the conditions section. If that condition evaluates to true, we'll create that resource. If that expression evaluates to false, we won't create that resource. We'll just skip it. So in this case, if it's a VPC region, I'm creating an EC2 security group. If it's a classic region, I'm creating a DB security group. Then I need to be able to select, when I'm creating the instance, which particular security group I actually want, and they're actually passed in as different properties. So in the case of a VPC, I'm going to pass in the VPC security group name. And I'm going to use the if statement that we provide that says if the EC2 VPC condition holds, then use the group ID from the EC2 security group that was created earlier in the template. And notice I'm using the same condition there, so we can guarantee that if this condition holds true, then I already created that previous resource. We also have a special value, in this case called no value. What that does is, if a conditional expression evaluates to no value, we'll skip that property, so we won't pass that property to the underlying service. So in this case, if I'm in a classic region, so is EC2 VPC evaluates to false, we won't pass the VPC security group's property to RDS when we create that database instance. So that gives you a way to selectively decide which resources you want to create, and then selectively which properties you want to pass to the underlying services. So that's kind of what we had for today. Just kind of in conclusion, we saw kind of the CloudFormation Designer overview, and hopefully you guys are excited as we are for that. We talked a little bit about CloudFormation in your organization, as well as some advanced concepts and some best practices. So thank you for coming. Fill out the evaluation forms. That's definitely good feedback for us.